remains to find out the answer for the last part are, so it says that the M be a skew-symmetric matrix such that the entries are again from the set T for I greater than J. Then the number of elements in the set X, Y, Z. Okay, so now we have to find the number of elements in the set, in this set. So how many these X, Y, and Z are possible? X, Y, Z, the total vectors, how many possible to satisfy this? So first of all, M is a skew-symmetric matrix. So what is the condition of a skew-symmetric matrix? So for the skew-symmetric matrix, we have diagonal entry 0. We have all the diagonal entries to be 0. And so this is 0. And if this is 1, 2, this is 1, 3, this is 2, this is 2, 3. So this entry depends on this. This is going to be A12 minus of A12 because the skew-symmetric matrix satisfies this condition. So using this condition we have, and this will decide this, and this will decide minus A23. So this is going to be our matrix. And the entries are going to be from T only. Entries from T only. So now we have to find out. So the entries are from T. This means that A12, A13, A23 are from T only. Are 1 alpha, beta. So the entries are from here. And the XYZ should be like M multiplied with this XYZ should be A12, 0 minus A23. So what is it actually giving to us? So this is XYZ. You multiply it with this M, you get A12, A13 minus A12, 0, A23. So minus A13 minus A23 0. And this is XYZ. You get 0 minus A23, and this is, I think, A12. This was A12. This was A12, yes. So we have to find how many such X pairs are, such vectors are possible. The XYZ. How many are possible? We have to find the number of these vectors. So that means how many solutions of this equation or the linear equation in 3 variables. So 3 linear equations are there and 3 variables are there. So you can solve it. You can use the elimination method, or you can determine using the matrix method as well. So for using the matrix method, you need to find out the determinant of this matrix M. So you need to find out the determinant of this matrix M. Now, if you solve it using the basic method, like 0 multiplied with the, you calculate the minors and cofactors and all those things to calculate the determinant. So if you use that method, that is also fine. But for a skew-symmetric matrix, of odd order, this has order 3 cross 3. It has dimension 3 cross 3. So if it has any order 5, 7, but the order is odd, and the matrix is skew-symmetric, so the determinant will always be 0. So if it is given that the matrix is skew-symmetric and it has an odd order, so what is the possibility of its determinant? It is every time going to be 0. It is 0. So this is 0. That means unique solution is not possible. Unique solution is not possible because for the solution to be unique, what do we need? We need determinant of m to be non-zero so that we can take this determinant, they take the inverse of this matrix here and we can easily solve for x, y, z. But this is not happening in this case. We are getting the determinant to be 0. This is 0. That means unique solution is not possible. So either this is the case of no solution or infinite number of solutions. So x, y, z possibilities are either infinite or 0. No solution is possible. Infinite number of solutions. So this is a case of infinite or 0 number of solutions. But if you see carefully that if you want this entry to be 0, that means if you multiply this x with this, z with this, x with this, and y with this, you need it to be 0. And at the same time, you multiply x with 0, a12 to be with y, and a13 to be with z, and you want a12. So if you keep z to be 0 and y to be 1, you will be getting a12. And for this to be 0, if you keep x to be 0, your second equation will give you 0. And to check whether this is actually a solution of the system, you multiply x with minus a13, you get 0 because x is 0. And this is minus a23 and this is 0. So yes, you are getting minus a23. So that means this 0, 1, 0 is a solution of the system. 0, 1, 0 is a solution of the system. That means this is not the case of no solution possible. It is the case of infinite number of solutions. So the answer for the part R is infinite. This is 3. So once we mark it, this is C option. Because S was 5, using the column operations, column transformation or operation, we use this. We use that and we deduce that S is 5, R is 3, Q is 4, and S is 2. So this is invalid. It doesn't have any part as its answer. So C is the final answer. C. So thank you so much for watching this video and see you in the next video. Till then, happy learning.